dy dx instead of changing y over changing x. That is, for a straight line graph, we usually use change in y over change in x, which is the rise divided by the run. And to find the slope, we are going to use this formula. However, consider a point on a curve, and this point can be choosing any point or anywhere along the curve. Let's start by choosing 2 points along the curve. You can see that x here is x1, while x2 now becomes x plus change in x, and y1 becomes f of x, while y2 becomes f x plus change in x. And with this development, our slope for a straight line graph will now change to this. At times, mathematicians represent change in x with h. In this comparison, we are trying to use what we know about a slope to obtain a slope that changes instantaneously along a curve. Here, we are trying to get the slope at a point and not at 2 points. And you can see that these 2 points will still give us a very large increment. However, we are looking for a very tiny increment towards this point. Hence, I will start to limit this triangle so small that the limit is running closer to 0 but not equal to 0. By so doing, I will now obtain dy dx. This is the concept of limit functions in precalculus. Next, this formula. Change in x can be represented as h and also can be represented as x plus h in bracket minus x, or as x plus change in x in bracket minus x. Your lecturer can decide to use any of them, because this minus this is the same as this, which also can be represented as h. But if you decide to use h, then this change in x will change to h. Just be consistent in your choice. Now you have known the difference between these slopes of a straight line and of a curve. I will see you in the next video.